Okay guys, what's up? Welcome back. Welcome back to erbsclass and 5-minute math. And this is that example I was talking to you about for conditional probabilities or tree diagrams. We're gonna use a tree diagram to solve this one. So let's read on. J and E are both given a math problem. The probability that J solves it, 0.35. Now if J solves it, the probability that E solves it is 0.6. And if he doesn't solve it, the probability that the other person solves it is 0.45. Now we have multiple things going on here, multiple events, multiple decisions. Let's give a V for our first decision. Okay, bang. So shorthand, J is either good or J is not good. So what's the probability that J solved the problem or that J is good? The probability according to the problem was 0.35 probability that J is good and he solved the question. So if that's the case and this V has to add up to 1, what's the probability that J is not good and he doesn't solve the question? Exactly right, 0.65. Now, depending on how J does, that's how we're going to determine how E does. All right, so it says if J solves, the probability that E solves it also is 0.6. Sounds like we need another branch for that. We're off of this branch first. Good. So if J solves it, the probability that E solves it also, 0.6. Shouldn't that go on the E good line? Good. And then finally, if there's a 0.6 probability that she solves it, that means there's a 0.4 probability that she doesn't. Good. Now there's a whole nother branch for if J does not solve it, so we're gonna need that down there. Exactly right. So now we're on the J not solving branch, and if he doesn't solve it, probability that she does, good. Okay, and then finally, if it's 0.45 chance that she does solve it, there's a 0.55 probability that she doesn't. Good job. All right, so advice. Go ahead and multiply out these routes and get your final probability because most of our answers will come from those final probabilities. So I'm gonna go ahead and multiply through each one of these routes and get my final probabilities. Okay, there you have it. There are all of my probabilities for each way this situation can pan out, right? Quick check. If I add all of those together, shouldn't they add up to 1? If these are all of my possibilities, if I add up all of the probabilities for all of my possibilities, it should be 1. Let's see. Yep, they all add up to 1. All right, so here's my tree diagram. Here are our final probabilities. Let's answer some questions. Okay, so here we go. First off, I want to find the probability that at least one student solves the problem. Now, first off, at least one, doesn't that mean one or more? So I need the probabilities for one student solving it, doesn't matter which one, or for both students solving it, right? Because I want at least one, it means one or more. So if both students solve it, I saw that fits this description also. So let's talk about what we have here. These final probabilities, let's talk about what they mean. Doesn't that first probability, J was good, E was good, they both got it right for that first probability, right? Oh yeah. What about this second probability? J got it right, but E did not. Okay, all right. Down here on this route now, J did not get it right, but E did. And now finally on this last route, J did not get it right, E did not get it right. So this is the probability that both of them got it wrong. Okay, so let's talk about what we want. Which of these probabilities fit this description? At least one student. Did at least one student get it right here? Yeah. Did at least one student get it right here? Yeah. Did at least one student get it right here? Yeah. What about this one? Did at least one student get it right here? No. So we're not going to include that one, but you know what I will include? All 3 of those. Exactly right. Now, do you remember what we do with these final probabilities when we're working vertically? Add them. Oh yeah, so bang. Exactly right. So remember, calculate all your final probabilities, but then our answer is going to come from that. All right, I got one more question. One more question. We're going to kick it all the way up here. Okay, this is kicked all the way up. You see those 2 special words that we always talk about? Given that, right? Changes everything. It even introduces a new probability rule. Let's put that rule up here now. When you see a given that, there's a rule specifically for given that. This rule is huge. When you're doing conditional probability, compound probability, any probability where there are multiple steps involved, This line right here, that line means given that. Exactly right. So if I want to know the probability of J solving given that Elisa has solved, this is the formula I'm going to use. Now I'm going to change some things. I'm going to change some letters in here just to make sure we can apply this rule to this problem. So everything that comes before given that goes before that line is A. Good, so I changed them A's to B's. First event, A. Second event, given that Elisa solved. So given that Elisa solved, we're gonna call that E. Good, okay. Now most of these things are right here on our picture already, so let's talk about that. What's the probability that J solved it and Elisa solved it? J's good, Elisa's good, bang. That probability of J and E happening, boom, 0.21. Okay, good. Now, we need the probability that Elisa solved it. Now, there are two situations here where Elise solved the question. You know where they are? Exactly right. In both of those situations, Elise solved it. So the probability for Elise solving is the sum of those two numbers. So we got to put those in my denominator. Oh yeah, don't forget to add them together before we divide, and that's going to give us our final answer to this question. Oh yeah, exactly right, exactly right. Hopefully this helps, man. We're going to do some more of this in class, but let's give you a good place to start. Thanks for checking it out, man. I'll see y'all next time. Bye.